Hey there. In this video, we are going to actually practice drawing different three-dimensional figures. We're going to start here with some prisms where we're going to be given length, width, and height. We'll eventually move down to some cylinders right here where we'll be given the radius or the diameter and then the height. We're going to also, after we draw these figures, we're going to find the volume. We're going to just practice finding volume of the 6 shapes that we're about to draw. Okay? So let's get started here where we have a length, a width, a height, all of 5. So it's a 5 by 5 by 5, and I think that you guys already could tell that that's going to be a cube. So we're going to start here by drawing a square. Okay. Now I know I have the computer, and so I'm going to try to do it as if I didn't have the technology to make things nice and perfect so that you guys can kind of practice drawing with me. So I'll just draw a square. All right. Now we basically want to draw that same square, just kind of sharing a corner. Okay. And now we're just going to connect the edges here and here. We're going to connect those corners and those corners. And so it's obviously not perfect. Some of you are going to be better on your paper than I am here on the computer drawing with my mouse. And I'm just going to label here the 5 inches by 5 inches by 5 inches. So we have the length, the width, and the height. Now I'm going to use this cube to just review that when I think about this, like to me, length is this, and then width is this part right here. So for the video, I'm going to be treating this side as the length, and then I'm going to be treating this side as the width. And I just draw an L in cursive just because if I put a 1 like that, like a L like that, it might look like a number 1. And then we don't really use capital letters when we're labeling these things, so I just don't want to do that. So that's why you guys see me using a cursive L there. Okay. So yeah, for this video, I'm going to be basically thinking of it as this is going to be the length, this is the width, and then this right here is the height. And sometimes you might prefer to measure the height right here to label it over here, and that's okay. So you might also see the 5 on that side. All right. So I had the 5 originally over here, but you might prefer to see the 5 labeled over there. And that's what I'll put over here, and that's how I'll leave it just for the rest of the video. All right, cool. So there's our cube. And again, we have the length, the width, and the height all figured out. Now we also just want to practice finding the volume of all of these just so that we're good with this. And I'm going to review with you all that you can actually use the Desmos. So I'm going to open up a Desmos tab here. And I want to remind you guys that if we're trying to find the volume, we're going to use length times width times height. And so for this one, if we have length times width times height in there, we're just going to put that the length is 5, the width is 5, and the height is 5. So that would be 125 cubic inches, 125 cubic inches. Okay, that's the volume. All right, now we're going to move on to the next one where we have a length, a width, and a height. And even though this one was pretty easy because it was just a 5 by 5 by 5, my strategy here that I'm going to recommend is that we take the length and the height, and that's going to be how we start out. So the length is 10, so I'm going to draw a 10. Okay, so to me, however long that is, I'm going to label it as a 10. Now, if that's 10, the height needs to be a little bit more than that because we don't want it to look like a square. And I'm going to move that down in a second. So you can see here, boop, boop. All right, so there's the 10 and then there's the 12. So that really helps us kind of gauge the length and the height. And then the width is only 5. So the width is half of the 10 here. So I'm just going to go like here, then here, and then one more. All 3 of those lines kind of are parallel to each other. And then you can just drop a line from here to here. And then you can connect right here. And then we can put a 5 like right there. And there is the 10, the 12 is the height, and then the 5 would be the width like that. So we just drew a realistic prism given these dimensions. Since the volume is length times width times height, which is really easy, you're just multiplying the 3 numbers, you can keep the Desmos formula open and just replace the values, or you can use right here, you could just say, okay, I've got the 10, length times width, which is 5, times the height, which was a 12. Sorry, I hit plus. Sorry, it was a 10 times 5 times 12. There we go. So that'd be 600. So this one is 600 cubic feet. We just multiply the three numbers for volume. All right, and now we are on the third prism, where again, you can see just based on my strategy, if you just start with a line and say, okay, that's my length, and then however long it is, you just draw the next line kind of compared to that for the height. It really helps you draw this front rectangle, and then you can kind of gauge, again, how long the width needs to be based on that. So here the length is 5 and the height is 3. So if I have a length of 5, so okay, here's a line, and I'm going to let it represent a 5. 3 for the height is not quite as long as that, so my height is not quite as long. And you can see this is a realistic 3x5 rectangle. Now this one, the width is much longer. It's double this. So our lines really need to go extend back here and here. Again, those are kind of parallel to each other. Mine's are, you know, a little bit crooked, and that's okay if yours are too. So we'll connect there, and then we'll drop a line to connect here. And then that's realistically a 10 because we can see that it's twice as long as this measurement of 5. So that's how I like to draw my shapes when I'm just given the dimensions. I usually start again with the length and the height, and then based on what I've drawn, I kind of gauge what the width needs to look like. And then again for the volume, we're just multiplying, and we can even do this one in our heads because you guys know that 5 times 3 is 15. And if we do 15 times 10, that's going to be 150. Friendly reminder that the formula is actually saying like the length times the width, which would be the 5 times the 10. And the 5 times the 10 kind of gives you the area of the bottom here. And once you know the area of this bottom, which is a 50, now you're going to do the 50 times the height of 3. And 50 times 3 is still 150. So we get the same answer. And that's how volume works. You've got the area of this bottom part right here, and then you're multiplying it by the height. So that also makes sense over here that the pi r squared, that's the area of the circular base for the cylinder. And then you're going to multiply it by the height, and then we'll have found the volume of our cylinders. Okay. All right, I just need to put a 3 here because I need to label this cubic inches because we're dealing with volume. So we just got done practicing drawing our 3 rectangular prisms given the dimensions, and then we found volume. Now we're going to move down here and we're going to practice drawing 3 cylinders, and we're going to use this formula right here to find the volume. Now, because I had Desmos open, I'm going to go ahead and switch out the formula. We're not dealing with the boxes anymore. We're going to do 3.14. That's for pi. The radius is going to get squared, so I'm going to hit this button, and then we're going to do times h. And let me back these up. Here we go. Cool. All right, so we have Desmos ready to go, and let's practice drawing these. So for the first one here, our diameter is the distance across the circle, and it's going to be 6 inches. And the diameter across is the exact same as the height, okay? So for this, let's start by just drawing kind of an oval right here. And the distance across, we can just draw a straight line. That distance across is a 6. That's going to be the diameter. Now the 6 that I just drew is the same as the height. So we do kind of want this to make like a square. So see how this and this are the same length? So I'm just going to kind of extend that up, and you can kind of see basically that's a square. Now I'm not going to draw, I don't want you guys to draw that top line right there. You can just draw the height here. And it's just that same oval. Just kind of draw that same oval again right here. And you've got the cylinder. And you can put a 6 right here, and now we can see that the diameter is 6, and it realistically kind of looks the same as that height right there. So this makes sense for the first cylinder. Now for the volume of this, friendly reminder that we need the radius. So for the radius, I'm going to draw that red line, and that means the radius here must be a 3. So we care about the r being a 3 for the volume. So for the volume of this thing, we've got r is 3. We know that the height is going to be a 6. So let's take a look at Desmos here. All right, so the radius we just said R is 3, and then hit enter. H here, the height of the cylinder is 6. So right here we have our answer. We have 169.56, and that's going to be cubic inches. All right. Cool. Now for the next one, our diameter is 12, and then the height is 15. So the distance across is a 12, and then it's going to be taller than that distance across. All right, so I'm just going to start with an oval. And again, my distance across the diameter here, I'm going to label is the 12. Now that line is a 12 in this problem, so I need something that's a little bit longer, and that's going to be the 15. Now again, you just kind of basically draw that same oval, and then you connect right here, and we can label the 15, and this is now a realistic cylinder given these dimensions. Friendly reminder again, for the volume, we care about the radius, so I also care about this being a 6. And so we're going to use that for the formula in Desmos, that the radius is 6, and we have the height here is 15. So I like to just, again, keep that calculator open whenever you're working on these problems, because now you can just say, okay, for this problem, my radius is 6. My height for this one is a 15. I'm just going to swap those numbers out. And then, oh, those are similar numbers. That's kind of ironic. All right, and so for this one, we get 1,000 and then 695.6. 1,695. Is that right? I feel like that must have glitched. Let me do 3.14 here. The radius is 6. I'm going to do radius squared times 36 and then times the height of 15. Yeah, look at that. 1,695 and then 0.6. That is really ironic. What are the chances of that happening? All right, and so then this is going to be cubic feet. Very similar numbers for the answers there in those problems. All right, and now for the final one here, we are given the radius is 5. Okay, so notice for the first two, we were given the diameters, and for this one, we have that the radius is 5. And then the height here is a 4. So if the radius is 5, the diameter is a 10. So we just kind of got to consider that as we're drawing this, that the distance all the way across in that one would be a 10. And therefore, if the height's only a 4, we don't even want it to be half as much. So this is going to be kind of a short, fat one. And then this would be a 4. And then like we had given here, the radius is a 5. So I can just label that up here that the radius is 5. All right, cool. So then if we know the radius is 5 and the height is 4, we can just swap those out on Desmos. All right, so the radius here we set 5. The height, we're swapping out 4. All right, and that one actually works out pretty clean. We get a 314 cubic inches for the volume. Awesome. So what we just got done doing is actually just practicing learning how to draw some of these 3D figures. Your artwork might end up being better than mine. Some of you I know are pretty great artists, and some of you might it might kind of just look like mine does, and you might not be very good at drawing these figures yet, but that's why we're just kind of practicing with this video. What we did for these 6 problems, y'all, was we found the volume using one of these 2 formulas. All right, so we just got done using finding the volume. Now when you guys come down here, all right, when you come down here, you're going to be drawing these shapes, but afterwards, you're going to be practicing finding surface area, all right? Surface area. So instead of filling up the shapes like we did up here, you're going to basically be practicing covering up the shapes. So to cover up the boxes, this would be the formula that you're going to plug into Desmos, and that would be for this one, and this one, all right? And then when you're coming down to these 3 right here, for the cylinders, you're going to be covering them up using this formula right here. And that's just practicing the topic from earlier in the unit. This one was kind of a more recent topic, finding volume, so I just did that one with you, but I didn't want you guys to forget about surface area. So these are the formulas. You certainly can use Desmos, but like I'm saying, just make sure you come through here and switch out the formulas. So if it's the box, you're typing in this one, D2LH and then 2WH, and then just again tell it what length, width, and height equal. And then for the next set, you're going to be typing in, you've got 2, and then it'd be 3.14 for pi. You've got radius, which is getting squared. Whoops. Then it's going to be plus 2, friendly reminder, 3.14 again, and then RH. And then down here, you just need to tell it what the radius are and what the height would be. Okay? All right, so then when you get done finding the surface area and drawing each of these, you're going to put those answers into a Google form. And that concludes this video. Thank you for watching.